Let's simulate a printer network by implementing a queue data structure and use it to solve this problem. I'll start by declaring my queue class with a private list, add a capacity as well, which I set in the constructor by ensuring it is greater than 0. I'll set my getter for the size, which simply returns the list length, as well as is empty and is full. The main methods in queue are inQueue, dequeue, and peek. For inQueue, we take an item and check if there is no capacity or the size is less than the capacity before we push the item to the list and then return the size. For dequeue, we simply return the result of calling shift method, which removes the first item in the list and returns it. The peek method returns the first item. Print simply logs the list. And that's all there is for a queue implementation JavaScript. As you see, it is very simple, but yet very powerful. Let's test it out by instantiating the inQueue some items. Print. Then the queue and check the items return, and again print the queue. As well, it is empty, it's full, getters. All good. But this is nothing if we don't use it for a more elaborated example. So let's simulate a printer with a queue data structure. First, let's create a printer, which is a class that extends our queue class. In the constructor, we will call the queue with 10 for capacity by calling super. I will also add an ID for the printer just to be able to identify it. And the printer will have a single public method called print that takes a document and returns a promise. And inside, if the printer is full, I will reject with the message that the printer is full. Otherwise, I will inQueue a function that, when called, resolve this promise with a document. I will also create a private method to print documents that will go through the queue and print all the docs, and I need a isPrinting flag first. Now, inside the print method, if it is not already printing, I will call this print document method. The print doc set printing to true and start, and I set timeout to simulate a document taking time printing, and I will set duration to be random between 0 and 2 seconds. Inside, I dequeue and call that function to resolve that document. Now, if the queue is empty, I'll set printing to false, otherwise call print docs again and continue to print the entire queue. Let's try this by creating an array containing 10 items with numbers 1 to 10 and print them. When printed, I simply log that the numbers is printed and the doc returned. And notice in the console, we see when they are all done, and each takes different time to print. More importantly, they all follow the order in which I request the printing. I'm gonna add a catch block and bump this array size to be 15. And we see the doc 11 to 15 are rejected and the others print. This rejection is not okay because as a user, now I'm forced to go find another printer. Make sure they are also not full and or wait till one frees up. A lot of work when all I want to do is click print, and when it's done, it tells me which printer so I can go get it. For that, I'll create a printer network class that handles all this. It has access to all printers and manages to find a printer for me, knows about what all printers are doing, etc. So I create a printer network class that also extends the queue and contains a private list of printers. These are all the printers connected to the network, and I'll add 3 printers for this. The network also contains the print method that takes a document and returns a promise. The naive way to handle this would be to find which printer in the list is not full and use it. But that's not very efficient as it only moves to the next printer when one is full, and we want the documents to be distributed among them for faster printing time. The best way is to find the least busy and hand the documents to be printed. Otherwise, add the document to a waiting list until one becomes free. I use the reduce method on the list and initialize the reduce with the first printer. All I do is check if the current printer has smaller load than the previous and set it as the printer to be used, then return it. Now I check if this printer is full, If so, I enqueue a function that calls the printer method, and then it resolves this promise with the printer ID. Otherwise, I call print on the printer. And again, then I resolve this promise with the printer ID. And since this printer is done, I check if the network queue has document. If so, I'll dequeue it. And remember, it is a function, so I call it to resolve it. This is all we gotta do, but to better explain this, let's pretend all printers have capacity of 1 and we have 4 documents to print. We call print for all the documents, and the first 3 each will be assigned to a printer, and the 4th will be added to the waiting list. As soon as one is done printing, it checks the waiting list. If there is something there, it dequeues it and then calls it, which inside calls the print method again, which then discovers our recently freed up printer and uses it. And when that is done, the waiting list is empty, so it stops. Now to visualize this, I'll create this array of numbers and call the printer network to print. And we console a message with the doc printed and the printer ID. We can make this list of 3 and see that every printer gets a doc. If I make it 4, we see that the first freed up printer got reused for the 4th doc. You can see the better if I make all the printer take 2 seconds. And we can always make this print 100 items if we want, and the load is distributed. Now you know how powerful this data structure is. Please check the source code below, and once again, thanks for watching. Catch you on the next one. Bye-bye.